Okay, so this is problem 12-204, and we're given this pulley set up here, and we're given that VA is, this motor is winding this thing up at 8 meters per second, so 8 meters per second to the right, and what we're looking for is the velocity of the block down here, the velocity of this here. So there are two cables. There's one cable that's attached to the motor that attaches to C right here, and then there's another one that's wrapped around here. So we're going to have to use our dependent motion analysis to analyze this problem. And we're going to use this pulley up here as our datum because it's attached to the ceiling, it's not moving. So we're going to call this distance here SA. So we'll call this distance SA. And from our datum here downward, we'll call this SC, and this goes down to pulley C. And then we'll have SB on this side, and that will go down to our pulley B here. Okay. So we have two cables, so let's work on adding up the length of those two cables. So we'll work on this first one here, and that is pretty easy. That's just SA plus SC equals the length of 1. And the second cable is wrapped around here. So this length right here is, the way we've defined it, is SB minus SC. So that's this length. If this total length is SB and this is SC, this must be SB minus SC. And we actually have two of those. So we'll multiply this by 2. And then from here to here we have SB. So we'll add SB to that. And that's going to be the length of 2. Right? Move down a little bit. And we can further simplify this equation into 3SB minus 2SC equals L2. Now we'll work on taking the derivatives to find the velocity. So we'll take the derivative of this equation for the first cable, and we get VA plus VC equals 0. And take the second equation here and take the derivative. We have 3VB minus 2VC equals 0. All right. So the goal of this equation is to relate VA to VB. VB is actually attached to this block here, and that's what we're trying to figure out. And so we need to take these two equations and combine them to get this relationship. So taking this first equation, what I'm going to do is just, I'm going to take this first equation and multiply it by 2. So we're just going to take this first equation and multiply it by 2, and we get 2VA plus 2VC equals 0. Okay. Now with that equation, we're going to take this equation and add it to this equation. So the left-hand sides we're going to add together, which is going to be 3VB plus 2VA. And then when we take 2VC and add it to negative 2VC, they cancel each other out. And that's going to be equal to 0 then. So with that equation, we have the relationship between VB and VA. And VA we're given is 8 meters per second. So with that, we can solve for VB. So VB is 16 divided by 3, negative 16 divided by 3, which it then comes out to be, where do I have that? 16 divided by 3 comes out to be negative 5.33 meters per second. So what does this negative sign mean? Well, what the negative sign means is that we drew SB downward this way. So actually what happens as SA is positive here, SB is actually being pulled upwards. So that is equal to 5.33. 0.33 meters per second upward. All right, and that's our answer.